your next lesson, it's going to basically go along with the first lesson, 2-1 was one-step equations. Now we're up to 2-2, two-step equations. Now this is the title of your notes. Please make sure you make a nice title, underline it, highlight it, something nice. Don't worry about the picture here. I always tell you that's just a placeholder. And make sure you put the date off to the left, right in this area. So we're going to write our date and our title because we're starting a brand new section. So if I write in green, make sure you copy the notes. If I change to red, I'm just kind of showing you some extra things. You do not have to copy those, just like it said in the first set of videos. Let's get going. All right, our first equation here is a multi-step equation, so we have more than one step. Well, the question is really, we probably know what to do with this, and we probably know what to do with this, but the question is, which one do we do first? And I can answer that. We always work away from the x. So this 2 is right next to the x. We don't want to touch that yet. We always work away from it. So this plus 3 is kind of farther away. We're going to take care of that first. So the first thing I do is I take away 3 from each side. Remember, we didn't touch the 2x. It drops. We save that for the end. The 3 minus 3 becomes a 0. So I want to make sure I see a slash, a sideways slash, or some way that you're showing me that that's gone. That's a 0. The equals, we didn't touch it. 15 minus 3 is simply 12. And now it's a very basic one-step equation. The 2 is directly touching the x, which means this is multiplication. So I do the opposite, which is division. And the way I like to remember that, to detach a number from a letter, I divide. Now this is another important notation thing. Please do a vertical slash here, because what number does that look like? It looks like a 1. And the reason is this is not a 0x, this is a 1x. And I want everybody to understand that there's a secret 1 here. We don't show it, but it is a 1x. 12 divided by 2 is simply 6. We think we have our answer, so let's go ahead and make sure we do a quick check on this. You don't have to spend too long on the check, guys. It's very fast. We simply want to, now we don't even need to write the original. I'll just let you plug right in. So 2, now there was an x right here. We're not going to show the x. Now we're replacing the x. So when we replace, when we substitute, we put parentheses every time. 2 times 6 plus 3. We can do this all in our heads, hopefully. 2 times 6 is 12. 12 plus 3 is 15. Pretty easy start to the notes here. It checks out. Now we can circle this. It feels nice to circle that answer and know it is correct. So those are the steps. I want to repeat something. We basically work away from the x first, and then we kind of work our way into it towards the end. So let's look at the next example. And there's always some twists and turns with all these things. So let's see. Yeah, we see something here. We see a fraction. Not many people like those. So a lot of people want to deal with this right now. We don't want to deal with this yet. Just like the last problem, if I can go back a slide here, we have the plus 3. This time we simply have a plus 5, kind of in the same position. We definitely want to take care of the 5 first. So we want to get the 5 just out of here. That's quick and easy. Take away 5 from each side. Oh, okay. Take away 5. We end up with 1 half a times a dropping equals 13. Now we have a fraction, and it's right in front of a letter. If you go back, it looks very similar to this. And in fact, it is. I mean, 1 half is really the same thing as 0.5. So you could say 0.5a equals 13. There's a lot of ways you can look at this. Some people would maybe put the a on the top. That's okay. That's an acceptable move. But basically, the way I want to introduce this is, remember from the last lesson, if we want to get rid of a fraction, we multiply by what's on the bottom. So now we can get rid of this fraction. We multiply each side of this equation by 2. And these 2's effectively, we could say a cancel. You don't really have to understand what's going on here in this class. That's okay. But if you look what's left, a 1 and an a is left. So 1a drops, and it equals 26. And I'm going to erase this 1 here because we really don't show that for our final answer. Now, if I want to check my work, quick check here. 1 half times 26 plus 5 equals 18. Let's take a look. 1 half times 26, I can tell you the answer to that. That's 13. 13 plus 5, maybe I'll show my work. I should really show my work on that. So 1 half times 26 is 13. 13 plus 5 is definitely 18. And I'm a little out of space. Let me scroll down. 18 equals 18. So our check worked. And I can't stress enough how the check is a very important part of the game here. Substitution, and also when you're working with fractions like this, you have to make sure you're doing things in the right order. So please check your work on these. It's very easy to mess up. A lot of students will try to multiply by 2 right away. It can really throw off the problem when you're looking at the sequence of what to do. So now this one's a little different. It's a fraction, but I call this a long bar. Take a look. The bar it has 2 things on top, 2 terms on top, we would say. This one is a short bar. It only has 1 number on top. The 5 is sitting to the side. So these are 2 different problems, and this is where students get really confused. So make sure you're paying attention. We can't really get rid of them. There's no +7 or +2 over here. We can't really do much here until we take care of this, 6. So in this setup, in a long bar fraction, you have to take care of the denominator immediately. So we're going to go ahead and start by multiplying each side by 6. Now what's going to happen over here is a lot like what happened back over here. See right in this area? The 2's canceled. Well, in this case, the 6's will cancel. And what happens is this x plus 5 is going to drop. So x plus 5 is equal to 90. 15 times 6 is 90. All right. We are almost there, a very basic equation now. We don't want that 5. Now the 5's kind of hanging on, to the side here. We want to get rid of that. Minus 5, minus 5. That's now a 0, which is good. X equals 85. And I'm going to forego the checks just for the time. I think you know what to do. You need to take this 85, and I'm going to switch to red. That means you don't have to show this in your notes, but you're going to put the 85 right there. So effectively, it's going to be 85 plus 5, which is 90. 90 divided by 6 does equal 15. It would check out. But like I said, for time, I don't want these videos to be too long. I'm going to forego the check. But please make sure you're doing those. Let's look at the next setup. Looks very similar, but might be some trickier things in this one. We have a 3 to take care of immediately. And the way we take care of that 3, if you want to get rid of a fraction, multiply by the denominator. That takes care of the fraction. X minus 7 equals negative 36. And class, if you're having any trouble, please make sure you pause the video, take a look at the steps again. Take your time with this. We're almost finished. We're basically need to get rid of a, now this time it's a minus 7. Make sure that you read it as that. It's a negative 7 or a minus 7. So to get rid of that, we do the opposite, and we do a plus 7. That would make the 0. Plus 7. All right, the x will drop. The equals will drop. And now the way we read this is very important. It is negative 36 plus 7. So our answer to that would be negative 29. Circle my final answer. And once again, make sure you check your answers out. And it does check out. I just did that one in my head. Okay, back to one that looks like this again, a short bar fraction. So I'm trying to switch back and forth just to give you the idea what to do. If you remember back here, we started by getting rid of that 3. The way we do that is multiplying. So look at this problem. Do I multiply by 3? No. I know it's a little confusing, but if you take a look, it's a short bar. We actually have to get rid of this negative 8 first. So I'm going to go back a few slides just to show you it's very similar to this. We had to get rid of the 5 first. So if you have a short bar fraction, like we have here, if you have a short bar fraction, please take care of the stuff hanging off to the side first. That's the way I like to think about it. If you have a long bar fraction, you could go ahead and take care of the denominator immediately. Okay, back to what we're doing. We have to add 8 to each side. X over 3 will drop. This becomes a 0. Equals will drop. We end up with a 12. And now how do I take care of this fraction? How do I get rid of that 3? Remember, it's being divided, so I will multiply. X equals 36. Please don't forget to check. Okay, now it's basically on the other side of the equal sign. It should be very similar approach. We have a short bar with something hanging off to the side. Let's take care of that thing that's hanging over here. I see a -3, so I'm going to simply do a +3 each side of the scale. You are gone, that's a 0. This falls, m over 7 equals falls, and 6 plus 3 is 9. Very fast ending here to take care of the 7. How do I get rid of that fraction? I multiply by the denominator. So 63 equals m. And I like the variable on the left for my final answer. And this is totally acceptable. You are allowed to do this in math. Remember, they're equal. So if a scale is equal, could you switch what's on each side and will it still be equal? The answer is yes. You can do that. Okay, we've got one more here. This is probably the trickiest one. Let's go ahead and take a look. We have a short bar. So I'm thinking I want to multiply by 4. Nope. I've got this thing hanging over here, so I want to make sure I start out by adding 6 to each side. We got to get rid of that -6 first. That's gone. Let's get back over here. 3/4 x equals 24. And now there is actually 2 ways to look at this. I don't want to confuse you, so I'm going to stay consistent. We're going to multiply by the denominator. There is a little bit faster way, but I really don't want to confuse you with that other way. So we'll stick with this. We multiply by the denominator on each side. That makes the 4's go away, but there is still a 3 here. So a 3x is going to drop. 24 times 4 is 96. And we will ask ourselves what's happening here. This is multiplication, so we do the opposite. We'll do division. That makes a 1x, or x, equals 32. And that concludes the notes, except I would like to show you one bonus problem. Now, you don't have to put this in your notes, but I just want to kind of give you like a knowledge check here. It's going to be very quick. If I saw something like this, I'm going in red pen. You do not have to do this. Please pay attention for a quick moment. If I saw a problem like this, well, I'm a little confused because now I've got a long bar and I've got the thing hanging off to the side. And I will tell you, in this problem, the very first thing you do is take care of this. Just like back to this one, we had the fraction and the thing hanging off to the side. We take care of this first. If I showed you something like this, I know it's a long bar, but you still have this thing hanging off to the side. You take care of it. First thing you would do is do +8, +8. They would go away. I'm just going to go a little further in this problem. X plus 3, still over 2. We didn't even touch that. Would equal 18. And now I would multiply by 2 on each side. All right, I'm not going to finish this problem. I just want to show you, if you ever have a fraction, a long bar or short bar, and this thing hanging off, you take care of that first. So this is where practice comes in. So make sure that you take the time to do very good notes, and you work really hard at practicing and checking your answers. So experience is where you will really remember what to do when.